So what ESP transport mode will do is it will insert a header here in this field. So it has inserted a header called the ESP header before the layer 2 will come. Sorry, I missed the point. Sorry. The header is rather inserted here, over here.
Ronald.
Yes.
Please, are you still recording?
Yes, I'm recording, sir.
Ah, okay.
The header is rather inserted in this field, okay, after the layer 4. So ESP will now insert a header. If I say ESP, I mean AH. AH will also do the same. You can optionally use ESP or AH or both. So ESP will be here before the layer 3 and the layer 4. Please, is my voice clear?
Not all that clear.
I can sense so. All right, so layer 3 will come here, that's source IP and destination IP. Then layer 2, source MAC and destination MAC. So ESP acting in a transport mode is actually going to protect the information here. The protection is only here. After all, this is where the valuable information is, the payload. And ESP in the transport mode is protecting here. So the IP address of the actual packet can be seen by any hacker or anybody who wishes to see the IP. You can see, after all, IP address, what at all can you do to IP address? Nothing. So that is the tunnel mode. That's the transport mode. But with the tunnel mode, ESP is actually going to encapsulate the entire packet. Okay, so instead of inserting the packet in between the layer 4 and 3, the packet is actually going to be in front here, going to be added here, ESP, to protect the entire payload. So meaning the MAC address is hidden, the IP address is also hidden, but every packet will need a MAC address and an IP address to travel. In that case, ESP is actually going to insert an IP header, okay, and a MAC header. So it will add a source IP and a destination IP, source MAC and a destination MAC. We call this one the tunnel mode. So if you want ESP to protect your data fully, the entire data, then you are going for tunnel mode. But the transport mode is going to protect from layer 4 onwards, leaving the layer 3 information. Larry, please, can you hear me clearly?
Yes, please. I can hear you clearly.
All right. So inside this ESP header, you can have your AES for encryption. You can have your SHA-1 or SHA-2 or whatever it is for your data integrity and so on and so forth. ESP, in fact, is the powerhouse for encryption. It's the powerhouse for encryption. It does encryption very well. AH behaves like ESP in a way. So I'll not waste time to explain AH. AH can also be inserted as a header. Over here, in the...
Hello, sir.
Yes?
Question, please.
All right.
The source IP and the destination IP that comes after the ESP.
Yeah.
Please, is that one? How is it different from the source IP and the destination IP at the layer 3?
All right. So if you have configured tunnel mode on this router, now the source IP of this interface here, let's say if it's 3.3.3 and .3, that is what is going to be used. And the destination IP over here, 4.4.4.4, that's what is going to be used over here. Okay? You understand?
Sir.
And the MAC addresses will also come. Richard,
Okay.
you understand?
Yes, sir, I understand.
Beautiful. But the actual the packet itself is inside.
Okay.
Okay. AH can also do the same thing as ESP. The main difference between AH and ESP is AH is very good in authentication. It's very good in authentication, whilst ESP also does authentication in a way. But AH does not do encryption. Okay? It doesn't do encryption. Authentication header, all it knows is authentication and some data integrity. It does integrity as well. That is hashing. SHA-1, SHA-2, SHA-3, whatever it is. But ESP does encryption, it does data integrity, and it does authentication, CIA. In most cases, we use ESP in combination with AH because you want a strong protocol for encryption. So you like to use ESP, then you want another strong protocol for authentication. So you use AA. So in cases where both headers are used, then when it comes to encryption, ESP will champion that one, whilst AH will champion authentication. So that is how I can explain this protocol. They protect the payload. Okay? Any question, please? Okay. So we are still on IPsec VPN. Let me clean this. So now we have established that IPsec, let me represent it with a SAC. A SAC that has everything inside it. For confidentiality, you will have it. AES. For data integrity, you have it. For authentication, you have it. Everything is inside. Okay, that's where you can also find ESP and AH. They are all there. They are inside. Okay, so now coming back to site-to-site VPN. After understanding all this protocol stack, it will now be easy for us to explain the VPN technology. So now we are coming
Bossnut.
Yeah.
Sorry, before you go on, I didn't get it well. You said that layer 3 and layer 4, we can put a ESP in the middle, okay, like sandwich. At what point do we bring it back to where the MAC address is?
Please ask again. At what point do we bring it where?
I want to understand, you know, at the point in time you said we can bring the ESP in between the layer 3 and layer 4. Layer
Yeah.
4, layer 3.
Yeah.
And then you were also saying that on the header payload, we can bring it just after the MAC address.
Okay, so what I was explaining is, if there's a payload moving on the network, okay, this is your payload. If I say payload, I mean the data that you are sending, the voice that you are sending, the video that you are sending, they are all here. Then layer 4 information will come. Source port number, destination port number. Layer 3 information will come here. Source IP, destination IP. Then layer 2, source MAC and destination MAC address. This is a raw data. It's unprotected. You can either protect it with encapsulation security payload or authentication header. Either of these things. And this one has all the protocols inside it. AES, SHA-1, whatever it is, all the protocols that will make it behave the way they do, they are there. Okay? An authentication header also has, authentication header has SHA, all the data integrity protocols, SHA-1, SHA-2, MD5. It also has a very popular protocol that helps it to do authentication. And we call it HMAC. Okay, the name is Hashed Message Authentication Code. Hashed Message Authentication Code. It's a protocol inside the authentication header that helps this protocol stack to do authentication. This is a code that helps in authentication. Okay, so Ben, back to your question. Either of these things, you can insert one here. Okay, you can insert the ESP here. In fact, you will not do it. It's just a matter of configuration. Once you insert it here, we say you are configuring in the transport mode. Okay? In that case, your IP addresses are bare. It can be seen by anybody on the internet. But that's not a problem. But if you don't want the IP to be seen, you want the whole payload here to be protected, then you do that in the tunnel mode. That is where the packet will actually be inserted in front of the packet, thereby protecting the entire, so the IP cannot be hacked. In that case, the ESP is going to add an IP because every packet will need a source and destination IP, a layer 3 source, and also a layer 2 source destination MAC. So it's going to insert an IP here, a different IP, source IP and a destination IP, a different source MAC address and a destination MAC address, so that the packet can travel on the internet. But when it gets to the intended destination, all these things here will be decapsulated and the packet will be laid bare. Please, have I explained myself? Bernard? Bernard? Mr. Tuahine? Have I explained myself, please?
Yes.
All right. So let's move on. So IPsec configuration, we have phase 1 and phase 2. IPsec, you can talk about phase 1 and phase 2. What is the phase 1? The phase 1, the head-end devices here are going to talk to each other They are going to agree to create a channel. Okay, imagine something like a channel. We have all seen channels before. They are going to agree to create a channel over the internet. That is what the phase one will achieve. Now, after the channel has been created, now interesting packets. If I say interesting packets or interesting traffic, those are traffics that are intended to communicate with each other. So over here on this network, you have different subnet IDs. This one have a different subnet. So let's assume this subnet here is 192.168.1 and .0 /24. Over here we have 172.something, and here to 10.something. And this network too, we have 192.168.2.0 /24. And another, let's assume you have over. You see that private IPs, nobody has control over them, so you can choose it anyhow. Supposing my intention is I want pieces in this network to communicate with pieces in that network. I'm going to define the traffic here as interesting traffic. In that case, all these ones are not interesting. They don't intend to move on this channel or on this tunnel. They are not intended to move there. So in your configuration of IPsec, you have to define interesting traffic. How do we define interesting traffic? By creating access control list, ACL. I told you that time that access control list, you don't use it to block, either block or permit traffic, no. You use it to categorize traffic. So we are going to use access control list to define interesting traffic. All right. So after the phase one has done its job by creating the channel, now it's time for the interesting traffic to move through the tunnel. It's time for interesting traffic to move through this tunnel. And this interesting traffic, as I explained earlier on, even though they are moving in the channel, layer 4, layer 3, and layer 2, even though they are moving in a protected tunnel, you still want to protect the payload. Okay? This is VPN. You can't trust anybody. Fine, you have created a tunnel. The packet which is moving from end to end also must receive some level of protection. That is what phase two is intended to achieve. So phase two is where the interesting traffic moves through this tunnel here, end to end. And we call it IPsec transformed set. IPsec transformed set. This is the phase two. And that is where the interesting traffic move up and down. So you want to add some parameters, some security measures in the phase two. You want to use ESP. You want to use AH to protect the payload. You want to use both. In our case, we are going to use both. I also have in mind that the authentication header has a protocol SHA for data integrity. It also has hashed MAC, HMAC. Okay, also has it. Hashed message authentication protocol. I always forget the full meaning. ESP also has AES. It can be 256-bit. All the protocols here have small protocols inside them. That is what we are going to use to protect the payload in the phase two. So phase one, head-end devices are going to agree to create a channel. Then phase 2, interesting traffic will move through the tunnel. The configuration is very simple. Okay, the configuration is very simple. Let me explain for some space. Okay, so the public IP addresses here, let's assume the public IP here is 11.0.0.1. And over here we have 12.0.0.1. Once you're on this router, you should be able to ping your peer. Even before the VPN configuration, you should be able to ping. Okay? Because it's a public IP. Your peer should also be able to ping you. But they cannot ping this PC here because this PC is using private. At the end of VPN configuration, these devices here should be able to ping each other. All right. So now we are coming to look at the phase 1. Let's call this one router A and router B. On router A, configure terminal. Crypto IPsecVPN policy you give it a number. Then, which encryption do you want to use in the phase 1 encryption? Let's say you want to use AES 256 bit. Yes, that's what you want to use. What about authentication? Remember CIA. Confidentiality for encryption, data integrity, and authentication. So what about authentication? You want to use pre-share. Pre-share. Let me explain the pre-share. The pre-share is now in your minds. Okay, these are two different companies. You decide that, look, let's use this password. Tom Cat. Tom Cat 1, 2, and 3. So you are going to agree to use this. Now you will give to the administrator in company B that this is what we are going to use. And you also use it. So you have pre-shared the password. That will be configured here. If you don't do it that way, each time the devices set out to communicate, it will request you to enter a password. You want to automate everything. Okay, so you use a pre-shared key. And once you use a pre-shared key here, there is also another protocol. Okay, that is responsible for internet key exchange. Internet key exchange. So the password that you are going to set on router A must move on the internet to B, for B to accept or reject. Now it has to move on the internet securely. And the only protocol that can do that securely is the Diffie-Hellman. So we can also go and read on Diffie-Hellman protocol. Okay, we have Diffie-Hellman group 1, group 2, group 3, and so on and so forth. These are the names given to the protocol, okay? Nothing special. You only have to know that the Herman is responsible for internet key exchange. You understand? Nothing much. So this pre-share key, you are going to use the Herman group 2. It can be group 1, it can be group 5, whichever way. So I am going to choose the Herman group 2 for my internet key exchange. I've not entered the key yet. This key, TomTomCat123, I'll enter it. Now when I come to router B, still on phase 1, in fact, this configuration will be done by the administrator in this company. So you are going to share, you are going to agree, okay? Most of the time, you have to fill an Excel sheet. You have to, there's an Excel sheet that you fill, okay? So the Excel sheet, you agree with the company, okay, for phase 1, encryption, we are going to use AES256, and for the pre-share key, you don't enter it in the Excel sheet because it's a breach in security. You can either WhatsApp it to him or something. So you are going to agree on all the parameters and send emails to them. So the other company will also configure same. Configure terminal, crypto, IPsecVPN, policy. For the policy number, it can be different on the clients, the partners router. It shouldn't be the same. It can be the same though, but they don't have to be the same. Then for the encryption, it has to be the same. AES. Because if you choose a different encryption algorithm, they will not understand each other. Authentication, you also decide to use a pre-share. And the Herman group 2 for the internet key exchange. You have actually finished with the phase 1 configuration. But take note, you haven't entered the password. You have actually finished with the phase 1. Please, for lack of space, I'll be deleting some of the configuration. Okay, for lack of space. So, if you are jotting down notes, be fast. So, phase 1 is achieved partly. Wait for me to enter the pre-share key. Then it can be achieved fully. So still on router A, at this point you like to exit. So you will exit, and on router A you exit. When you exit, you come to the global configuration mode. Then this is how to share the key. Crypto, IPsecVPN, key. Then you enter TomCat123. You continue with address. It's on one line. Address. So over here, you are going to refer to your peers, your remote IP. So address 12.0.0 and .1. You understand? We are doing the configuration on router A, but we are referring to the public IP of router B, because that is what we are going to share our public key with. Crypto IPsecVPN key, you bring your key, and you continue with address, public address of the remote end. You're coming to do the same on router B. I said you, not you. The other administrator is actually going to do that configuration. Please, are you there?
Yes.
All right. So over here too, you have crypto ISACAM key cat. The password must be the same. Continue with address. And so you are here. You are going to refer to this public IP. 11.0.0 and .1. So now phase 1 is achieved. You want to configure the phase 2, the transform set. Remember, the phase 2 is you are going to set the parameters for the messages to move on the channel, protected. And that's the configuration. Crypto, IPsec. Please don't think I'm writing a command from my memory. No, I'm looking on something. So don't be so disappointed in yourselves. If I'm on the router, I'll use the help to assist me do that. That will not be a problem. But writing down commands, I'm not that sharp. So crypto IPsec transformed set. You are going to give it a name. This transform set, you are going to give it a name. 1 minute, please. Okay, so you are going to give it a descriptive name. Let's call that name Nat or Natty. Then, after you've given it a name, you are going to encapsulate it with ESP and the authentication protocol you wish to use is AES 256. It's optional. You can use AES 128-bit. You can use AES 192. But once you use 192 here, you have to use 192 on the other router. If you use 256 here, you have to use 256 on the other router. Okay? All right. Then you want to add an authentication header, AH. So we are using both ESP and AH to protect our data. And mind you, anytime ESP is used in combination with AH, ESP will do the encryption side of it, and AH will do the authentication. So for AH, it's going to use the SHA-1, and it's also going to use the hashed MAC. You know this protocol? We talk about it. That is what is responsible for the authentication. This will happen on one line. So crypto IPsec transform set, you give it a name, then you define which protocol you want to use for the encapsulation security payload. We use this protocol for encryption. What about the authentication header? We use this one for data integrity and this one for authentication. Then the other end will also do the same, but the names here doesn't have to match. However, the protocols must match. The protocols must match. So the other administrator will also configure crypto IPsec transform sets. You can name it to, let's say, Bob. You want to use an authentication header of SHA and...
Mr. Nat, is that on router B?
Yes, this is on router B.
Abab.
All right. Then ESP, you want to use AES 256. Please, every protocol you use here, make sure you use the same protocol, otherwise it will not work. Phase 2 is achieved. Phase 2 is achieved. So VPN configuration, you have to put these steps in mind. You have to put these steps in mind. First of all, configure phase 1, which we have done. 2, configure phase 2, which we just did. 3, define interesting traffic. Anytime we define interesting traffic, we use access control list. Okay, we use access control list. So how do we define interesting traffic? I want to say, okay, anytime this subnet as a source intends to communicate with this subnet as a destination, phase 1 should trigger. That is the idea. In defining interesting traffic, you mention the source and the destination where the packet is going. So that if the packet gets here, supposing you are here and you ping 192.168.2. Let's say this one is 2.10. So source is this, the 1 network, and the destination is the 2 network. Once it hits this router here, phase 1 will trigger. Then the head-end devices will communicate, create a channel. Then phase 2, interesting traffic will pass through. And how do we define the access list for the interesting traffic? So still on router A here, access list, because we are using both source and destination IP, we can't use standard access list. It has to be extended access list. So access list 150. If the source is 192, what do we say? The keyword is permit, sorry. If the source is 192.168.1.0, it's a /24. So let me bring the wildcard bit for /24. That's 255. And the destination is that. If it's going to this destination, so 192.168.2.0, it also has a wildcard of 0.0.0.255. I've defined interesting traffic. This command is for